Welcome to this video on the logic of hypothesis testing. After watching this video, you will be able to define sampling variability, define the phrase statistically significant, and define hypothesis test. Sampling variability. In past chapters, we have learned about sampling variability. Remember, sampling variability simply means variability among samples. For example, if two people roll the same die 10 times, we do not expect those two people to have the exact same 10 outcomes. This is known as sampling variability. It is important to remember that as our sample size increases, sampling variability decreases. Sampling variability or something else. Because of sampling variability, we do not expect a group of sample statistics to be identical to each other. We also do not expect a sample statistic to be identical to the population parameter. In hypothesis testing, we must answer the question, is the discrepancy between the population parameter and the sample statistic a result of sampling variability, or is there enough difference between the two to cause suspicion? Let's look at this example. A political candidate wants to know if she can expect to win the majority of votes, meaning more than 50%, in the next election. She obtains a random sample of 100 constituents and finds that 53 of them plan to vote for her. First, let's construct the null and alternative hypotheses for this example. To learn how to do this, please watch my previous videos. The null hypothesis is that the political candidate does not win the majority of votes, meaning that p equals 0.5. The alternative hypothesis is that the political candidate wins the majority of votes, meaning that the population proportion is larger than 50%. Now let's answer the question. Based on the sample data, can the political candidate expect to win the majority of votes? The sample proportion, p hat, is 53 over 100, or 0.53. 53% is more than 50%, so can we simply say that according to the sample, the political candidate can expect to win the majority of votes? Pause this video, write down your thoughts, and then unpause it to see if you're correct. Unfortunately, a simple comparison of these two values is not sufficient. After all, the difference between the two values could merely be caused by sampling variability. How can we know for sure whether the difference between the statistic and the parameter is due to sampling variability, or whether it's actually cause for us to reject the null hypothesis? To answer this question, we use a hypothesis test. Statistically significant results. In statistics, we use the term statistically significant to indicate we are seeing a discrepancy between the population parameter and the sample statistic that is more than just sampling variability. We say that results are statistically significant when they cause us to reject the null hypothesis. A hypothesis test is the process by which we determine whether the discrepancy between the population parameter and the sample statistic is an indication of a change in the population, or whether it is merely due to sampling variability. Having watched this video, you should now be able to define sampling variability, define the phrase statistically significant, and define hypothesis test.